Okay, we're going to talk about covalent bonds. We just finished up ionic bonds, so we're going to talk about covalent bonds. So first thing you have to know about covalent bonds is it is composed of two nonmetals. Okay, whereas ionic bonds were composed of a metal and a nonmetal, a positive and a negative. These are going to be composed of two negative ions. Our nonmetals are to the right of the stair step on your periodic table. So if our stair step is right here, we've got boron, and then aluminum, silicon, germanium, there, and arsenic, and antimony, and tellurium. So basically anything to the right of the stair step can be viewed as a nonmetal and can be used in covalent bonding. So some of them are most of them are metalloids. So you can kind of, especially boron can be used either way, but most of the other ones are purely used in covalent bonds for our purposes. Okay. Second thing is covalent bonds share electrons. To ionic bonds which transfer electrons. Okay, so when we talk about ionic bonds, we talk about like sodium completely getting rid of its valence electron, and chlorine completely accepting that electron and becoming the positive and the negative ions. Covalent bonds, they just share the electron between the two. Okay, so we'll get into naming these. Naming covalent bonds is pretty easy. There's no crossing over. There's no simplification. Super easy. Okay, so naming covalent bonds, the first thing you're going to do, step number one, is name the first element with prefixes. And I'll tell you what the prefixes are here in a second. Okay, what you are never going to do, never use mono as your prefix for the first element. Okay. And then step number two, you're going to name the second element with prefixes add IDE to the end, just like we did in the beginning when we were working with just one nonmetal in an ionic bond. We're going to add IDE to the end. So like ionic bonds with sodium chloride, magnesium fluoride, bromide, iodide. Okay, we're still using that that suffix there at the end of the word. So what are our prefixes? All right, we've got 10 that you need to know. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first one is mono. All right, number 2 is di. All right, so 3 is tri. 4 is tetra. So like Tetris, if you've ever wondered why Tetris is called that, because you get 4 in a row, and that's Tetris. But anyway, 5 is penta. And a lot of these you'll remember from geometry or some math class. 6 is hexa. 7 is hepta. 8, octo. Nona is 9, and deca is 10. So remember our first step, we're going to name the first element with the prefixes, but we're never going to use mono. So even if it's just 1, we're not going to throw mono in there. All right, so let's do some examples. We'll do a couple of formulas to names first. So C2H3. So how many, first thing you got to do, well, C is carbon, okay? And then we've got 2 of them. That's what these subscripts mean. And how many of each element do you have? How many atoms of each element do you have? So you have 2 carbons. So you have dicarbon, okay? And then you're looking here, hydrogen. How many do you have? 3. So it's tri, and then hydrogen is hydride. So dicarbon trihydride, you have 2 carbons, okay, and 3 hydrogens. No crossing over, no simplification, super, super easy, okay? Next example, SO4, okay? What's S? Well, S is sulfur. You only have 1, so you're just going to write sulfur, not monosulfur, not monosulfur, because you never use mono in your first element, okay? And then you have oxygen, and you've got 4 of them. So, tetroxide or tetroxide, it really doesn't matter. Usually you don't put two vowels together. I really don't care if you do that, as long as you know that oxygen is oxide and 4 is tetra. I don't care if you put it together. Now you may be asking, well, SO4, we just did SO4 as sulfate. Sulfate has a -2 charge. This doesn't have a charge, so it's not a polyatomic ion because there's no charge right here, so it's not an ion at all. Okay, so that's the difference. Let's see, one more. Now we'll go on to names. Okay, so going from the name to the formula. So if I gave you iodine difluoride, okay, first thing you're going to do is look at this one, iodine, find it on the periodic table. It's an I. How many do you have? Well, it doesn't give you a prefix, so you got to have 1. Okay, so you don't put a 1, just like in ionic bonding, you don't put a 1. All right, your next one, fluoride is fluorine, so IF, and then you've got di. So you look at your prefixes. Di means 2, so it's IF2. Do another example. Nitrogen monosulfide. Nitrogen. Nitrogen. Tri means 3, so you put a 3 as your subscript. Next one is sulfide, that's sulfur. Mono tells you 1, so it's just a 1. So here's your answer, N3S. Okay. Last example, dinitrogen. Tetroxide, it's very sloppy. I think you get it. Okay. Nitrogen, N. Di means 2, so you put your subscript of 2. Oxide is oxygen. Tetra is 4. So this is your answer. Do not modify covalent bonds. error. There is no simplification. There is no crossing over. Covalent bonds, super, super easy. Okay? As long as you memorize the prefixes, you should be good to go. Okay, so that is naming covalent bonds.